Okay, so before moving on and actually doing computations using this thingy and so on, I'd like to just clarify what is this integral over c of the curve or the line c of f of x comma y ds. What is this really? So this, first of all, has just been copied from right here, and in a sense, this is the picture, but I think because it's drawn, it's kind of hard to tell. So I'd like to try to clarify with a um, little thing that I made. And so we'll start with z equals f of xy. Let's start with the function here with the two input variables, x and y. So this is, the graph of a function, right? And so this is going to be the blue surface in the picture we're about to take a look at. So some time ago, I created this, and it just kind of lives in my office. You have here in blue, right here, this wavy thing. It's right here. I basically bought some felt, and then I took this metal wire thingy that's easily bendable, but once you've bent it, it stays in place, and I glued that in with a flap, and so I could basically bend. It's like a glorified very long paper clip, and I could just bend this so that it creates this super waviness, and this passes the vertical line test, and that's up here. Next, there's the capital C, right? So C is supposed to be a line, or more generally a curve. Right? It's called a line integral, even if it should be called a curve integral. And so C is represented by the paracord. Let me clarify what I mean by that. So let's go back to the picture. So the paracord is this blue, basically glorified shoelace thing. It's very long. And what I did was I took this and also wrapped it in this metal wiry stuff so that it can easily bend. And I glued it down onto this yellow felt. So you'll see it down here. Yeah. You'll also, I guess, see it clearer in this version that has more light. You see a little gap over here. The paracord should be touching my the desk in my office the whole time, because this curve should really be two-dimensional in nature, but I kind of screwed up a little, right? So there's a little bit of gap here. You can kind of see through a little bit into the wall back there. I guess same problem here. That's just an accident. I did the best I could. And then the question really becomes how much area is the yellow felt, or the yellow curtain, let's call it. The answer to this question, that's what the integral is. So let's go back and look. Okay, so this integral really represents the area of a yellow curtain. What yellow curtain? It's this one. So what happens is there's this curve here. Yes, this paracord in blue is not making a straight line, but above at this point, I wanted the curtain to be all the points that are directly above until you hit the roof. Same deal right over here. I wanted all the points that are directly above until you hit the roof, and you might hit the roof at a different spot. Now over here you see this kind of bend. That's an accident. I didn't want that, but it's just hard to prevent some of these things. So from here, move directly on up. And basically, how did I actually implement this? You'll see over here, I use a lot of glue and a paper clip and so on. But what did I really do was I actually started with this flattened piece here because I had to work off something. And I just basically used some scissors and I just made a random kind of curve-like thing. And then I kind of took this and propped it up. So this piece here, it's currently upside down from where it is here. And I just took this and then I took the yellow piece and I bent this shoelace part until this curvy thing fit perfectly with the roof, best as I could anyway, and then I glued this on. So you imagine this kind of thing, like there's this really cool building with a really wavy roof, and you're inside the room, and then there's a curve that's been sharpied down on the ground, right? The ground is flat, and then there's this curtain, and there are hooks. This curtain's height isn't the same everywhere, as you notice from this yellow piece right here. The height of the curtain is determined by the height, or what's the point of the roof that's directly above the point of the Sharpie. And so that's why so the curtain has different height in different places. It's based on whatever the function is, that surface. And so if you were to be able to unhook, so there's like hooks everywhere in the roof, let's say, and then you just hook the curtain in at the appropriate location because the height of the curtain is just perfect. If you undid all the hooks of the curtain and you laid it out flat, it would be this thingy here, this yellow thing, and you're trying to find that area. I'd like to try to demonstrate this same thing again using an app. So you'll see here an attempt of the same thing. So there's it's not the same as the one that I made, using the craft materials. How could it be? But there's first of all a curve C. That's the line, so to speak, of the line integral. I just kind of made it a wavy little thing like this, and you'll see that down here under the yellow drawn in black. Okay, and then you need a function f of x comma y. In my case, I chose x over 3 plus x squared over 40 plus sine of y plus 4, only because it's shown in blue here, and it mostly looks like parabola. It's just copied along, but there's a bit of a ripple effect, and that ripple effect is caused because as you move along the y-axis, I guess this way for positive y values, there's a sine of y that creates a little bit of an up and down like thing, and I think that ripple made it a little easier to see in just a moment what's going on. So we are looking at all the points that are directly above any of these black points, but under this blue surface. And so let me kind of rotate the picture over here, and just due to the ripple, you can kind of see it back here, the effect of the sine of y. You can see that here, this shape is not quite exactly what you'd expect. Like how the roof meets this yellow is, it kind of has this a little bit of irregularity. Maybe I don't know if this is going to work if I turn it upside down. Maybe the XY plane is getting in the way. I think this is actually going to work. So you'll notice now we're looking from directly underneath. Yeah, we're on the floor below. Now there's a we're one floor below, and as we look up, this black curve that represents C, it's perfectly hiding the yellow curtain. If we just do this a little bit, we can see a little bit of it. So from, let's say, right here to, you see that shadowing to right there, that's going perfectly up. From here to there is going perfectly up, perfectly in the positive z direction. So let's kind of rotate this back so we can see a little better. If we took, should we rotate it around once? I don't know if that helps or not. Let's just do that. Okay, so if we took this yellow curtain here, it's all the points that are, so take any one of these black points on this curve here that's been just drawn on the xy plane, and you take all of the points, shade in yellow, all until the moment you hit the blue. And so then that creates this fabric yellow curtain, and if you took this yellow curtain and it's been hooked or attached at all these spots here on the roof, maybe I'll zoom in for a moment. Yeah, like all these locations right here, it had been attached to the ceiling. Let's say you undo that and you take this yellow curtain and you iron it out so that it just stays flat on the ground, say, so you can calculate the area. That's what the integral right here represents. This is the moment that I'd like to try to bring up the interactive question. It is, I would admit, a challenging one, but I think it's worth trying. So, interactive question. Do the best you can with this. Okay, so the actual integral. Right? I mean this thingy right there, yeah, is the area, is represented by the area of a yellow curtain, of a curtain. Now use words, use your own words to describe the approximation. Given by the Riemann sum. Just to say this slightly differently, what object's area, maybe I'll have to pick several objects altogether, but what object's area would be the Riemann sum and would closely approximate this thingy here, the actual area. the actual curtain area. As a hint to answering this question of what kind of object could possibly be the Riemann sum itself, go back to the picture that we already have of a Riemann sum. So look to that as a hint for what, use words to try to describe what kind of shape we're looking at.